Hello students, let us discuss a problem on laws of motion in this video. So in the question it is given that an unknown mass m1, this is our unknown mass m1, hangs from a massless string and descends with an acceleration equal to g by 2, which is also mentioned in the problem. The other end is attached to a mass m2 which slides on a frictionless horizontal table. The string goes over a uniform cylinder of mass m2 by 2. So the value of mass of the cylinder is given as m2 by 2 and radius is equal to r. Now the cylinder rotates about its horizontal axis without friction and the string does not slip on the cylinder. That is, we have to consider the rotational motion of the cylindrical pulley as well. Now we have to find, in first part of the question it is asked that we have to draw the free body diagram for both the cylinder and the two masses. In the next part, it is asked the value of tension in the horizontal and vertical section of the string. And in the last part, we have to find the value of unknown mass m1. Let us first draw the free body diagram of mass m1 by considering the value of tension in this portion of the string to be equal to T1, and in the horizontal section of the string I am considering the value of tension to be equal to T2. So let us now draw the free body diagram of m1. For m1, the first force acting on the block will be its force of gravity, that is m1g in vertically downward direction and T1 in upward direction. It is given that the acceleration of this block is g by 2. So this is the free body diagram of m1. Similarly, free body diagram of m2 will have first force equal to gravity acting in vertically downward direction, that is m2g. The value of normal reaction exerted by the surface will be in upward direction. T2 will be directed in horizontal direction. And this block will have an acceleration of g by 2 in horizontal direction. So this is the free body diagram of mass m2. Now for drawing the free body diagram of pulley, we can say that the two forces acting on the pulley apart from hinge forces, I am excluding the hinge force from this free body diagram. The two forces apart from the hinge forces will be the value of tension T1 and tension T2, and apart from that the value of weight, that is equal to, it is given that the weight of the pulley is m2 by 2 into g. Apart from that, hinge force will also act on this particular pulley, so we can denote the value of total hinge force by the two expressions n1 and n2. So this is the free body diagram of pulley. Now let us proceed to part B. In part B, we have to find the tension in the horizontal section of the string. So from free body diagram of m2, we can say that the value of T2, in part B, the value of T2 will be equal to m2 into g by 2, mass into acceleration. Now for solving part C, for the pulley, we can say that the torque will be due to the two forces T1 and T2. So the value of net torque will be T1 minus T2 into R, and this torque will be equal to I into alpha. This is the value of I for pulley into the value of alpha will be equal to A by R. So from here we can write the expression of T1 as T1 minus M2G equals to M2G by 8. Here I have substituted the value of T2 from case B. I have substituted the value of T2, and now we can find the value of T1, which comes out to be equal to 5M2G by 8. Okay, now let us proceed to part D of the problem. In part D, from the free body diagram of block M1, we can write the value of M1G minus T1 will be equal to M1 into A. The value of A was already mentioned to be equal to G by 2. So we can write m1g minus t1 will be equal to m1 into a. Now again substituting the value of t1 that we have already found, we can solve this expression to find the value of m1 in terms of m2, which comes out to be equal to 5 m2 by 4, which is our final desired result for part D of the problem. Thank you.